All right, I'm going to continue on. I just covered the table script. And since the scaling of the table is so intimately related to the placement of the containers, I'm going to just cover what's happening with the containers. So, first, I built the containers. So, I made a prefab of them. I just want to make sure that they're there. Yep, okay. So, what I did was first I want to mess around. What does a container mean? What should it look like? So I just ended up making a cylinder that kind of sat on the table. I'm going to scale the table back to its starting spot. And it's just a game object 3D cylinder. And it just has a little bit of a transparent, it's a standard shader, but it's transparent, and I just made like this blue. I'm not really thinking about colors. At least they kind of match and go well. I'm not going crazy. And that intro to visual design talks a little bit about like colors that complement each other. So a basic brown and blue seem to just match well. So it's a cylinder, has a transparent material on it. It doesn't have it's not a physics object. And let me see if there's any. Let me open up a prefab of it, and just before is there anything else in it? No. Okay. So I just want to make sure there's no children objects before I just say that. So the reason that once you make something and you've gone through a lot of efforts making all the parts of the game object and you're happy with it, you just drag game object down into a folder, in this case a prefabs folder, and it like saves a copy of it to file. And the benefit of that is that you can instantiate it or create it at runtime over and over and over again with all different placements and scales and whatever you want to do to it dynamically at runtime, as opposed to just having to place everything in the editor and then like turning a whole bunch of stuff on and off. So anyway, prefabs, it's like creating a permanent saving this complicated game object to file so that you can write it to memory as many times as you care to at runtime. So in this case, it's just size, and I know I want it transparent because I want the elements to be within these containers so that you can count them and get this idea that every element or index in the list can hold stuff. It's a placement. In this case, it's holding a number of these little spheres that bob up and down. But that's how I became to the feeling of what a container is. And then I kind of placed them and I figured out what I would like when there's 2 containers and 3 and 4 and how much spacing do I need between them. And these are just for placing guides, so I know the numbers. And notice how, but they still exist, I just turn them off because I never know if I need to go back to them. So that's all this is. And ultimately, that's how I know the positions of where I'm going to spawn containers based on how many containers I need to spawn. So the container manager has a script on it, and it has a bunch of containers. So 8 containers. All right. So we have up to 8 containers because that's the most that we can use in a game. So yes, the benefits of spawning objects at runtime are great, but it can be expensive. And so this idea of object pooling, or figure out how many you need at a given time, and you can just turn on and off smaller subsets of them. So I know I'm going between 2 and 8 containers throughout the whole experience. I could just have all those 8 containers created, just turned off, and I can turn them on and off and place them and animate them and make it look like I have this infinite pool of containers when I really don't. I just have a few. And if I look through here, that's everything that's dealing with the container manager. So let's open up the script and take a look at it. So this is a pretty lengthy one. So there's a bunch of parameters. Variables up here. I'm going to leave them alone for a second. So let's see. Void awake. When we awake, or turn on, in this case, it's only once when the game first starts. We go through all the containers length, and let's see, what are containers? Okay, that's our array here, and each container equals the transform of get child of the game object, container content 0. All right, so this is the containers that it's referencing. So private game object and array are a collection of game object variables. We're going to call the whole thing containers equals a new game object and array of game objects size of 9. And it's a serialized field, so we can see it here in the inspector. So that's what it is right now. And I probably made it serializable and exposed to the inspector so I could watch it and see at runtime when I was kept fixing. You know, all this code doesn't just work magically at the beginning. I don't get all my algorithms correct. Things are just not doing what I thought they would do. And so you're going to have to, having your variables exposed and watching as they fill and what are they connected to at runtime is really useful. So this array, a collection of game objects, they're all empty. Eventually they get filled up based on how many containers are live in the at playtime. Let me click play and you'll just see that. Let's spawn 2 containers. Oop, I gotta hit the button. Sure. So what happens when I hit the button is these 2 containers of my little pooling are activated. And here they are. If I click on one, there's this one, and there's that one. So it looks like all the containers, fill up the array. Okay, so it looks like that's what's happening on awake. So normally when you're dealing with collections, arrays, or lists, you're going to loop through them with for loops. And the iterator variable is usually an integer you set equal to 0. So collections start at element 0. We just count from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8 is a collection of 9 objects. It's just how it works. So for int I equals 0, and I is less than the length of the containers. So length is just a member method that returns the length of the array. So yes, I already know what the length is. It's 9. You can just put it here, but you should steer away from hard coding as many variables as you can. So if I did need to change this list, I just need to change it up here, and it will be reflected here. I don't need to go down here and change it. That's why you see stuff like that. And then increment I. So what this means is we keep looping through this for loop, similar to while loops. But in this case, we start at I equals 0. And this needs to evaluate to true. I less than the length of the containers, which is 9. So 0 less than 9, true. So let's run the code. Containers 0 equals the transform dot get child 0 dot game object. Okay. So this transforms you can grab children objects by saying transform dot get child, and then it's very similar to a collection array. You have to specify the child position. So this is position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it just so happens that there's 9 children. Well, technically there's 10. I have this rotation center thing here. But I'm going through the container.length, so 9. We're going to go from 0, as long as I is less than 9, so really to 0 to 8. So container 0 equals transform.getChild0.gameObject. So we go to the transform, and we get child 0, which is the first one, and we get its game object, and we assign container 0. We reference this game object. So that is why, and then we move through, and then we also say container contents equals, I'm just zeroing out this whole array of 9. I'm just zeroing it out at the beginning. So we'll get to what that is later, but they all get zeros. So that's why when I click play, we loop through 0 to 8, and we assign containers 0 to 8 to the game objects in position 0 to 8 as children underneath container manager. So we click play, and this fills up with these containers. So you could drag and drop these two. That you don't need to do it this way. You can drag each one over and fill this out too. I just didn't feel like, that's like the lazy way. I didn't feel like filling this out, so I just read them with my code. So that's what's happening at awake. It basically fills up that container, that array of game object called containers. So we have a method here when button is pushed. We can deal with that later because the button hasn't been pushed. We have update container and UI positions. I don't know if this is called right away, so I'm going to shrink that. We have list is in order, so that this is checked if the list is in order and what we should do. We have a cleanup containers. We have populate containers. Since it's a public method, this one's probably going to be called first. Depopulate, reset containers, and an enumerator. This is our animation. Something's happening in here. We're swapping containers, so that's how the two of them kind of do that rotate, move around each other. Move containers, set listener state. And I think this is going to be the main thing that kicks everything off. All right. So let me just check level. And I'm pretty sure that the set listener state, is the thing that kicks off everything. All right. So public override set listener state, whatever the state is. We have this big switch statement. That structure is always the same. Notice there's a whole bunch of cases. And all the other methods should one way or another be called from this stuff, except for button pushed. Let me see who's calling populate containers. Let me just take a quick look. Container manager, UI control. Okay, UI controls is calling this. And the level manager. Okay, and when is the level manager calling this? Reset containers. Okay, when we need to reset the containers, it's calling populate container. All right, so I don't need to worry about that right now. We're not at that point. So the beginning of this container manager is here, set listener state. And notice we have a whole bunch of other methods, and I don't even need to go into them. I did do awake because that thing is just called right away, so I had to figure out what that was doing. So let's set listener state. So when we first start, we're going to move to introduction to next button. It's going to reset the containers. I don't need to worry about the debug statement. All right, so reset containers to 0 with a passing in an integer. And if you don't pass in an integer, it defaults to 0. So I have a float. So this is the Y height that I figured out the containers need to be. The move time is calling from the level manager, which I already figured out is 2F. So switch, we have another big switch here, and we're only checking 0, 2, -2, 3, -3, 4. Okay. So later I'll explain why we have positive and negative numbers. But so integer 0. We're going to go to the switch. We're calling 0, so this is going to be called. Let me see if there's anything after this. Nope. So what's happening at case 0? So we loop through our containers array, which is those 8 containers. And right now they're all hidden. They're all turned off. So each of the, we're going to go through all 8, 0 to 8 are all 9 of them. We're going to go through and set all their positions to 0. So, okay, 0, 0, 0. So where are they right now? Just turn them on real quick. They're all sitting at 0, 0, 0. I'm just resetting them, making sure they're at 0, 0, 0, because there might be some situations where we're not starting at new runtime where everything's already zeroed out. So level depopulate container. So we're going through and depopulating the containers, but we're going up to the level manager. So let's take a look. Oops, I want to go level. All right, here we go. Depopulate container. So we're going through each container, 0, 1, 2, 3, 4, 5, 6, 7, 8, and we're depopulating. And then, so what does that do is it goes up to the level manager and it calls depopulate container for, it calls this method 9 times for 0 to 8. And it says for everything that's listening to it, call it depopulate container. All right, so our listener script is being implemented on the UI controls, which we'll look at next week. But we see it's calling the UI controls in the container manager. So the container manager is resetting the containers and the level. And it happened to also impact the UI. So I was going up to the level manager saying, hey, you better let everyone know I'm depopulating the containers, because it looks like other stuff besides the container manager needs to know about. So what does the container manager do? And it goes for each transform child in containers, container position, not transform, destroy the child object. Okay, so it's killing off or destroying all the little spheres that get created in the container. So if I just play the tutorial as these comes up, these little spheres that get created as children, when we depopulate the container, it's wiping it out. So I'm just checking beforehand, even though there is nothing in these containers when we start runtime. I don't know if we're ever going to jump back to this situation. So it's like playing level 1 but getting stuck, and then there being a button saying, I want to go to the tutorial right now and run the tutorial because I'm not understanding something. So if I did want to implement a feature in my app where I said, oh, we can go from level 1 to the tutorial, I'm going to want to depopulate all this crap that's already spawned out in the scene and refresh back to our 0 state or our depopulated state. So this code doesn't make much sense to run it right at the beginning if you don't plan on going back and forth, but it's like safety proofing your code as you move forward, because you might need to wipe out everything that's in the container, jumping back to this 0 state, this first enumeration. So that's why. Oh, that sucks. Did I open all this stuff again? Hold on one sec. Oh, I'm sorry. That's the tray. Container manager. So that's why we did depopulate container call right here. And then that's it. There's nothing else to do because we're sitting for the next button to be pressed. But when the next button is pressed, we know that we can move into intro to swap. I'm just going to double check. Yeah, that's the next one. So somebody moved the hand and it did press that button, and I'm not covering the buttons right now, but just know that the buttons do have code on it, and it calls the level manager and says this button was pushed, and then we do a check and we say, oh, we should move, to the next task. So button pushed, if we're in the next button and the button that we pushed is next button, then we're allowed to move to intro to swap button. All right, so as we do that, here's the first time we actually do something with the containers. So let's look at this code, and then I think the container manager our big parts of the container manager script will make more sense. So this intro to swap button was pushed, and I want to spawn 2 containers that have some type of sphere elements inside them. All right, so container contents 0, and I'm doing a random range from 5 to 9. And then it's cast to an integer. So container contents is just an array of 9 of integers. So think of it as we can have up to 9 containers. Each of them can have a different amount of sphere objects inside of them. So this keeps track of the actual containers. This keeps track of what's inside each of those containers. So if container contents 0 equals 5, that's saying the first container should have 5 spheres within it. So container content 0, the first container in our list. We're going to randomly pick a number from 5 to actually 8. So the way this works is random range casts floats. Actually they cast ints here. There's no need to cast it again to an int. I thought these were being cast as floats. So return a random integer between min inclusive. Hold on a second. Sorry about that. A random integer between an inclusive minimum and an exclusive maximum. So it means we're going to go from 5 to 8. The max is exclusive. It's not part of it. So we will, every time we run this, we'll get a random number between 5 and 8, put it in our first slot in our collection, and then we'll get a random number between 1 and 3 and put it in our second. We're getting ready to spawn the first 2 containers. We're figuring out how many little spheres should be in those 2 containers. And it just so happens I want the first container to have more objects than the next one because that's when a swap makes sense. So then we call reset containers +2. All right, reset containers. You'll see why I set this float to this a little bit later. 2. So in this case, container 0 should be active. We're going to populate that container. We're going to animate it moving up. And then we're going to make the second container active. We're going to populate it. We're going to animate it moving up. And now we're setting some variables that we need to be aware of as we keep letting the user move through the list to know if the user has successfully sorted the list or not. So the first container becomes true. The game object's turned on. We go to level, populate container 0 with whatever the integer is in this element of array of ints. It was a random number from 5 to 8. So level, populate container. There it is. So it takes in those 2 ints and it tells everybody who's a listener to call this method. So I'm guessing I do this again because it looks like not only does the level manager have this method, but so the UI controls and container manager. So the UI must be updating in some way, updating text on it or what have you. But container manager gets populate container and int container position, int the content, how much spheres are within it. So for int I equals 0, I less than container contents of container position. So this container position comes in here. Actually, I don't even, in this case, I didn't use the content. Maybe I'm using that over on the UI controls, but I'm figuring out the content directly by saying container contents and container position. So this is that array of integers, and I know the position because the position is the container position. So this is saying, in this case, this is dealing with the first container. Remember, it was a random number. This evaluates to a random number between 5 and 8. So let's just say it was 5. We're going to spawn 5 spheres. So from 0 to 5, so 0 is less than 5. We're going to run this now, the first loop. And this basically sphere location, random range. So this is, I tried to figure out these positions within, this was a lot of just testing. Where is like all the random volume space within one of these containers that I can spawn a little sphere and still make it feel like it's within. So if I just make a little sphere, let me bring it in here, reset its position. So it's basically like saying how far in the X and the Z can I move it with it still feeling like it's within the container, not within the container, within. So there's definitely a plus and a minus and a plus thresholds where this thing can stay within the container and it still feels like it's within the container. It's not cutting through it. And the same with up in on the Y value. Where does it, what's all the random places I can spawn this, the plus and minus. So I figured out all those numbers, and that's what all this is. That's why I keep referencing container position, the transform the position X, Y, and Z, plus, minus, this and that. And I did a random call between all of them, and I get a random X, Y, and Z that is still within the cylinder sphere, the cylinder container that the sphere can be populated. So I'm going to instantiate this sphere. The sphere is a public game object. This one. And it's just a sphere, just like a Unity sphere, and it just has this random movement script on it. And all this is it just makes actually stole this from my binary math demo. And all it does is it makes the sphere bob up and down. I can tell it that it should be moving up and down, or it shouldn't. And this move up and down, actually I took this online, and it's Perlin noise. So it's a random number generator, Perlin noise. Perlin was a big person in the computer garage, still is, and he invented a lot of procedural algorithms that make a lot of interesting things, like when you procedurally make mountains and oceans and stuff, and then he made algorithms that could generate stuff that looked like this, semi-realistically, realistically. And anyway, it makes for this random movement up and down. And so I want these things to have a little bit of life to them. That's why this little script is sitting on a sphere. So all we're doing is just instantiating that sphere prefab, saving a reference to it, updating its position, and then setting its parent to the container's transform. So which one? In this case, it's this one, and then or this one the next, and what have you. So that's why when I clicked play, a bunch of the spheres eventually get generated underneath the container because I parent them with the code. So notice all these spheres live under this container. In this random calling, we have 6 on this side and 2 on that side. So notice they're all randomly placed within the cylinder volume, and they have this little random movement going up and down. Just give some interest to them. So that's the containers being populated with all these little spheres based on the element that it represents, the number it represents. So that was populate container. And then we move the container. And what are we moving? We're moving the first container in our list, our array. And this is where we're moving it from, and this is where we're moving it to. And then we start that coroutine. And that's move container. Very similar to the other one you've seen. What are we moving? Where are we moving it from? Where are we moving it to? Over how much time? While the elapsed time is less than move time, we lerp. And I've just covered the lerp, and I'm not going to cover it again. And incremental elapsed time. Eventually it moves. And to be, I should also, for consistency, have set its transform to its final transform position, end position, just to make it very precise, but I didn't do it there. And so that was the move container. We're on the 2. And then we do it again for the second container. We make it true, that game object, we fill it with whatever content we're going to fill it, and we move it up. And so this Y height of low that I hard-coded here, it's just so that the container is right underneath the table, and so it cuts right up through. So it makes it feel like the containers kind of float up through the table. So the containers are invisible inside the cube, the table. They get placed right below their position, then they just kind of move up. And that's that lerping. I said I want you to start here and come up. And yep, and all these hard-coded values, I figured them all out from that list. That lists all those references. I looked at them and see the numbers and I wrote them down. All right, and these all make sense later as we actually have the user moving through the list of containers, or as they're playing, and I'm testing, were they successful, not successful, and that's why I'm using these variables. So what happens after we set the containers? I think that's it, because then we just wait for whenever a swap button hits. So in the level, if a button gets pushed and it's swapped, then so whenever the swap button is active and it gets pushed, we tell the listener objects that, hey, this button pushed, swapped was pushed. And so if we come up, button pushed, if swap button, in the air. I'm doing some checks to see. This is only happening. The swap button was pressed to cycle true. Call the UI controls. Do some stuff to the UI controls. Oh, start coroutine. Swap container. All right. So there had to be some communication between the UI controls and the container manager, and normally I like to just the level manager to notify everyone with the listen manager with the listen objects and tell them different things that are going on. Since I was running late on time and this had to go out for testing, for user testing, I was starting to get some bleed through, some breaking of that concept. It was quicker for me, the container manager, to like call methods directly on the UI controls and vice versa. It was starting to get messy. So I should spend some time to refactor the code and have more of a cleaner like communication. But just know that that's why the container manager was calling methods on UI controls, and because these two kind of middle managers starting to communicate directly with each other kind of breaks some protocols and patterns. But it was, again, when you start hitting time limits, you kind of have to start cheating to try to speed up your development time. The only issue is it makes it harder to go back and to read through the code. So anyway, this is I'm not going to cover the UI controls this video, so I'll check into this, what the container manager is telling UI controls to do. But what I'm interested in is that we're calling the swap container coroutine. So this is another way you can say start coroutine, and you can pass in a string that's the name of the enumerator, the coroutine. So this is if you don't need to pass in any input variables. It's like you could just say call this method, but if you do need to pass in some input variables into the coroutine, that's why you see the other way I was doing it. So swap container. You saw move container. Swap container is another enumerator. Much lengthier. So we know that move time coming from here, that's going to be 2f. Elapsed time is 0 because we haven't started yet. We need a temp game object to do some swapping of storing of values. We'll take a look at that. An integer, another temp variable. So usually when you're swapping values in two variables, you need like a third temporary variable to hold it. Otherwise, you're going to overwrite one of the variable states. So that's usually when you see temporary variable, a third one to do swapping between two. Let's see, vector 3 left position. So I'm keeping track of which containers on the left side of the tray. You saw that integer earlier. I was setting it equal to 0. That gets incremented when the tray moves, when the user presses the next button. We keep track of this. So I want to know which container is always on the left-hand side of my tray. So if you remember, there's a container here and here. One's on the left, one's on the right. This tray can move through a longer list, and I want to know this tray centers up on two elements in the list, and you hit swap and they move. So I just want to know who's on the left, who's on the right. So whoever in the container list is on the left, give me its position, and who's ever on the right, +1 in our list would be the one on the right. Next. So as we move through the list left to right, we move through our array, top to bottom, our increase. That's why +1 would be the right-hand side. I needed this. I was having this. I'll get into this rotation center. It's basically this thing is just an empty game object. I'm just interested in the transform. I found that to do this, I think I'm using a slurp. I have to take a look at it. Slurp is like a spherical interpolation. So when you're moving, mostly dealing with rotating, when you want to rotate like around a perimeter of a circle, it's a different type of lerping. It's a different lerp and slurp. You're still like, should you move across a line or across a curve? Is how you can think about it. A lerp is linear across a line. A slurp is you're moving across a curved surface. So anyway, I was having these weird issues. I needed to specify the rotation center, so this thing gets placed in between the two spheres, and it just fixes my issues. So that's why I'm add the two vectors, divide them in half, and you get a center point. In our start rotation, quaternions are just a math structure dealing with rotations. You don't need to know the inner workings of them, but an identity is 0, 0, 0. Rotation 0, 0, 0. And our end rotation is Euler angle 0, almost to negative 180. Half a circle rotation. And so I just figured, it's just playing with these two containers. And if I move down here, oh no, it is a lerp. Okay, it's not a slurp, it's a lerp. Oh no, slurp. I am rotating, okay. So container on the left side, move the rotation. All right, let me hit the swap button and just take a quick look at what this is doing. I don't want to have to wait, so that's why I intentionally did this. Oh, all right. So I just want to hit the swap button. Oh, okay, one's going straight, one's rotating. So hopefully you can see that. Let me do a top-down view. And I'll just do that again. So watch the two containers. One's going along a curve and one's going straight. And if you notice these numbers here, this is why I'm communicating with the UI control. Now that you've watched the containers move, just watch these two numbers here. Oops, I moved something. There we go. See, these two numbers are doing something very similar. So that's why the UI control and the container manager are being made aware of these changes. But anyway, one of them is lerping, one of them is slurping. So that's why one is moving along a straight line, and I'm using this rotation center to get this movement along this curve to make it move along a curved line. And so, right, the start and end rotation. It seemed like going all the way to 180 was giving issues. So I'm moving very close to 180 or half a circle movement, but not fully because it was getting weird glitches. But that's how I'm getting one container. The container on the left-hand side is just lerping, left to right. And the rotation center is doing this rotation. Oh, and so the right container gets parented under the rotation center. Gotcha. So what's happening is this container gets parented under here, and this one gets rotated. Let's see, not that direction. Yeah, it gets rotated along the Y. And you see, because this container was offset, it's not the center point of it. It rotates around it like the Earth around the sun. And so it's only rotating half a turn, half a circle. And then I pop this back out. So I just temporarily place under here, and I pop it back out for ease of rotating. And then I precisely place them at the end of the while loop. I put the parent back on the container on the right-hand side. And they were swapped, so they need to be moved in the array. So that's why I need this temp object. So if we watch this transition happen, if you're watching on the left, you watched in these views, watch over here. This container will pop here, and then it'll pop back, but more importantly, the two of these will swap positions in the list. So let's watch them swap. Right, he pops underneath here, and now he's popped back out. Oh, that might not be what. Okay, here they're being swapped. If I do it again here, watch here. So notice container one. Let's do the swap. You notice how they're popping over here, but notice there that we move this container to the first element because it is now on the left-hand side. It's the first element in our list, and you're now the second, which is why they've swapped positions in this array. And that's what this is all about here. And that means that their container contents, now that they've swapped positions in the list, the list of actual contents that they hold, their positions need to be swapped. That 5 and 1, or whatever those two random numbers are, they need their positions swapped in here, right, too, because they've swapped positions in the kind of the master list of the containers. And everything goes back to normal. So that's swap container. And should that be all I cover? I guess I'll cover, so in this button pushed, if button next is pushed, what it does is it looks ahead in the list. And it says, are we getting toward the end of the list? And the way that I'm figuring that out is if 2 places ahead, so there's the container on the left-hand side, container on the right-hand side. If the next container in this list is empty, or is turned off, so if I click play, just let them spawn the list. We're at container and container 1. And then if I look down this list, the ones on my left-hand side is container. And if I look ahead 2, is this one turned off? Is it inactive? And if it's inactive, that's the end of the list. So if container on the left-hand side of the tray plus 2, if that object's turned off, I know that the tray is at the end of the list. It has the last 2 elements sitting on it. That's the last place we could swap. So if containers on the left-hand side of tray plus 2 is false, we are at the end of the list. And then I do a check. If we're at the end of the list and the swap button was not pressed this cycle, meaning we move through each element in the list and we never swapped. We just pressed next, 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 and we never swapped. We know that we did the final condition that I wanted you to do. That you keep checking if you should swap, and then if you're really sure you shouldn't be swapping anymore, you just move through the whole list in one cycle without swapping. Then I know that you, the user, are telling me, the game developer or designer, that you think that you're done sorting the list. So if we're at the end of the list and you haven't swapped at all throughout the list, then let's see if you're telling me you think you're done. So let's see if you're done. So int list check equals list is in order. So this is some method we're calling. Go to definition. So this receives no input and it outputs an integer. So for I equals 1, I less than the container contents length. So we're going to look through that whole array of integers that tells me the contents for each element in the list, the array. We're going to go see if container contents I equals 0, return. So I'm saying if whatever place we are in the list, container contents, if it's 0, pass out 0 through, just return, and the method, and pass back 0. It means they leave the last container is always unused as it's 0. I don't know, I put some comments in here. Means have lived, means container contents as unused as it's 0. Let me first see what these integers mean. So we can pass back a 0. We can pass back the I. So in I, how far along do we get? So if container contents I minus 1 is greater than container contents I, return I. So we're doing a check. If the container on the left side has a higher elements than the one on the right, then you haven't sorted correctly, because the opposite should be true. Everything that's on, if you check 2 elements in the array, the one on the left should always have less number in it than the one on the right. So that's why we say we start at int I equals 1, because we do a check. If I minus 1, and this needs to be 0 or greater. We can't start at 0 because it's going to be 0 minus 1, and we don't have element -1, and we'd get an error. So let's start at the second element in the list, because we're going to compare the first element to the second element. And if the first element has a greater number than the second element, then we should just return it, because that's the position that I have like a little hint system. The UI says, no, task was not successful, but this list isn't sorted yet, but you should check this position, this element. This is where you're having your issue. So this tells me that my UI, that task was unsuccessful. We can update the UI and say, hey, you should really check this position in the list, because you're telling me you sorted it, but we have an issue where we have an element that's greater to the left, and it should be to the right. And this is return -1. This is an error check. We should never hit this. We should hit one or the other in this situation. So this must be at if I equals 0, return 0. So this means if we're good. So if we keep iterating through this list, and this is never true, this never gets hit, then at some point we have to hit this, meaning we have to get to an element. That's why I have 9 containers, right? So I always have one extra container that has nothing in it, because eventually we have a list of, we only use up to 8 containers, but I have 9. So if we cycle through them all and we get to the one that has nothing in it, which the way I have it set up, none of these containers will ever be empty of little spheres bobbling in them if they're active. If we do get to a container that's empty, that has no children underneath it, that means we've successfully checked, moved through each element in the list, and that we never ran into a sorting issue. We never had an element on the left that had a greater number than the element on the right in that sorting tray. Think of the tray as you're moving through and you're checking 2 elements. So if this never returns true, eventually, even if we have a list of 8 containers, we get to that 9th container which has nothing in it, meaning no matter what, we get to return 0, which means, yes, you're correct. The list is sorted. All right, so who called that? All right, so if this bends back a 0, then task was successful. If this was greater than 0, it was unsuccessful, but you should check this number that gets sent back, because that's where the error, the issue in the list was. And then we should update the containers in UI, meaning the tray will like reset back to the beginning and saying, the UI will say, we'll blink red and say, sorry, you didn't get that right, but you should check this spot and try again. And then I have this else here, like if this is where we hit that -1, something's really wrong. We need to stop and check our code. All right, and so if we're not at the end of the list and we didn't hit the swap button all the time, or we did, if one of these, if we're not at the end of the list but if we are at the end of the list and we hit the swap button, then we go here. And we basically, this says we're not ready to test that the task has been done. Let's put the tray back to the initial position. And let's have the user move through the list again. So I think that covered. I know there's like a few smaller methods, but my voice is running out, and I gave you a huge overview of the container manager and how it's working. And that was, I think, this is one of the most complicated parts. I think it might be like the longest snippet of code I got. Before I say that, I'll look at the tray real quick. Yeah, the tray is a longer script, but it's not as complicated. There's a lot of setting. Set all these UI elements to this. Set them to that. That's why there's like so many commands. It's not as complicated to explain. It's just there's a lot more settings that needed to be done. So the container manager had the most complicated logic, and I probably covered like 85% of it, and more than enough to understand my thinking and logic as I built this out.